Birth rates in America are recorded by the NCHS, or the National Center for Health Statistics. The birth rate of a baby corresponds to a gestation period, which is the time between conception and the birth of the baby. For each gestation period, there is a mean birth weight and a standard deviation. The mean and the standard deviation for each point varies, and as the period increases, the mean weight and the standard deviation rise as well. This case study discusses the percentages of mean birth weights in each gestation period. This slide reviews the distribution of birth weights for each gestation period shown. The first graph correlates with the gestation period of 39 to 40 weeks with a mean birth rate of 7.6 pounds. The mean birth rate in the graph is between 7 and 8 pounds. The second graph is in correlation with 32 to 33 weeks, and as the mean birth rate is 4.3 pounds, and the mean birth rate on the graph is between 4 and 5 pounds. Lastly, the third graph is in relation to 34 to 36 weeks because the mean birth rate is 5.7 pounds, and the mean on the graph is between 5 and 6 pounds.
This slide examines the percentage of babies born with a low birth weight, 5.5 pounds or under, for each gestation period. For 28 to 31 weeks, the mean is 3.2 pounds and the standard deviation is 1.02. We took x, or 5.5, minus 3.2 and divided that by 1.02 to equal 2.25. We then looked at the standard normal distribution chart. From that, we got 0.9878, or 98.78%. We used the same formula for 32 to 33 weeks. This equaled 1.23. After looking at the standard normal distribution chart, we got 0.8907, or 89.07%. Using the same formula for 39 to 40 weeks, we got negative 2.12. After using the distribution chart, we found the decimal to be 0.0170, or 1.7%. Lastly, we looked at the gestation period of 42 weeks and over. After using the formula, we got negative 2.83. This was 0.0087 on the distribution table, or 0.87%. This slide discusses the weights of the top 10% of babies in each gestation period. For under 28 weeks, we took 1.6 as the mean birth weight and 0.76 as the standard deviation. Our equation looked like 1.6 plus 1.28 times 0.76, with 1.28 being from the equation. The outcome was 2.57 pounds. We did the same for 34 to 36 weeks using 5.74 and 0.76 as the mean birth weight and standard deviation. Our outcome for that was 7.19 pounds. For 41 weeks, we used 8 as the mean birth weight and 0.99 as the standard deviation for an outcome of 9.27 pounds. Finally, for 42 weeks and over, we used 8.16 as the mean birth weight and 1.12 as the standard deviation for a total of 9.59 pounds.
For number 4, it says, for each gestation period, what is the probability that a baby will weigh between 6 and 9 pounds? So for instance, for C, 37 to 38 weeks, the birth rate was 6.92 and the standard deviation was 1.07. The two numbers that I was using was 6 and 9. So I would take 6 minus the birth weight, which is 6.92, divided by 1.07, which is the standard deviation. I would get negative 0.46. I would do the same for 9. I would do 9 minus the birth weight of 6.92 divided by a standard deviation of 1.07, and I would get 2.5. Then I would take 2.5 minus 0.46, but you have to find the z-scores first. So for 2.5, the z-score was 0.9938. And the z-score for negative 0.46 is 0.6772, and it would come out to 31.6.
Under 28 weeks, 98.5% of the birth weight rate was less than 3.25 pounds. 28 to 31 weeks was 51.99%. 32 to 33 weeks was 13.79%. And 39 to 40 weeks was 0%. For the biblical principles of this case study, we decided to use Matthew 6, verses 25 through 34. And basically, to sum it up, it tells us, that Jesus says not to worry about our bodies since we were created in the image of Him. I think this relates well to the birth weights in America.